Okay guys, so we are in a new unit. I wanted to go ahead and show you the unit plan that you should have in your hands right now. If you notice, it's called Ratios and Proportions of Similar Shapes. It's actually 2 units together. There's only 1 lesson in Unit 5, and then there are 3 in Unit 7. And kind of put them all together because they're all talking about relationships and working on building up towards understanding like order and proportions. So kind of put them together for 1 unit just because Unit 5 only has the 1 lesson. So we're going to go ahead and take a look at the Unit 5 notes. And even though Unit 5 is only 1 lesson, this is a huge topic for the direction of the course. Lots and lots of potential test and SOL test questions and SAT type questions that are related here. And so it's a big idea, and so we'll make sure we take time and fully understand this. The first idea we want to talk about is angle-side relationships. So we've been dealing with triangles for 2 chapters now, and we've been talking about how, you know, the 3 angles of a triangle equal to 180, and then the 3 sides. We've also talked about how, you know, for example, if in a right triangle, the right triangle angle goes to the hypotenuse. And so, you know, that follows this angle relates to that side, this angle relates to that side. And so what ends up happening is you can talk about triangles and order angles and sides based on one information or the other. So essentially the rule is if one angle of a triangle is if one side, we did the side first. If one side of a triangle is bigger than another side, then the angle that is opposite the bigger side has a larger measure than the angle opposite the shorter side. Likewise, if one angle of a triangle has a larger measure than another angle, then the side opposite the greater angle is larger than the side that's opposite the smaller angle. Bunch of words, but basically this is what this means. Look at example 4. Which side is the smallest? Well, RS is the smallest. So then let's use some common number sense or some common relationship sense. If RS is the smallest side, what angle looks to be the smallest angle? Well, we can see here angle S is obtuse. That's obviously not going to be the smallest angle. So really it comes down to, is angle R or angle T the smallest angle? Well, what this postulate says is that if RS is the smallest side, then angle T is the smallest angle. So angle T is less than angle R. Okay? Now we've already talked about S is obtuse, so S is going to be the biggest angle. So angle T is less than angle R, but angle R is less than angle S. Now, if you can do that for angles, you can also do it for sides. But you need the opposite information, okay? So again, we're going to go from smallest to largest. Where's the smallest angle? It's right here. Angle T. So again, let's use some common sense here and look at the picture. Is RT the smallest side? No. Is ST the smallest side? No. Angle T points to the side of RS. And so RS is the smallest side. And that is less than the next smallest side. So here we have to we got to make a decision now, because we know it's ST or RT, but we got to make a decision. 60 degrees, we've already used this one. We're not going to use the one it's touching, we're going to use the one opposite. So ST is the side in the middle. And then obviously RT is the side that is left. Okay, so I've given you 2 pictures here, and obviously important to this is we need to know all of the angles. So again, 180 degrees in a triangle, this angle is 60, 180 degrees in a straight line. This angle is 120. So using that information, we can compare the lines to see which one would be bigger or smaller. Okay. So I want you to go ahead and pause the video and go ahead and do 6, 7, and 8. Okay. So AC is pretty long side, and it's across from a 120 degree angle. BC, pretty long side, across from a 60 degree angle. So AC is greater than BC. DB is across from a 30 degree angle. We already know BC is across from a 60 degree angle, so BC is greater than DB. And then obviously if AC was greater than BC and BC was greater than DB, then AC is obviously greater than DB as well. Okay. Now we don't know the lengths, but we know which ones are bigger based on the angle measure opposite. The same can be said if we know the lengths and we want to compare the angles. So angle R corresponds to an angle measure of 21.6 or 35, depending on how you look at it. But angle U corresponds, angle RUS corresponds to an angle measure of 38. See, we got both of those there. So angle RUS is much bigger than angle R. So angle R is less than. Angle T corresponds to an angle measure of 35. Angle UST corresponds to a side measure of 22. Well, 35 is bigger than 22, so angle T is going to be bigger than UST. Angle UVS corresponds to a side measure of 35. All right, and then finally, so like I said, UVS corresponds to a side measure of 35, and angle R corresponds to a side measure of 21. So we're going to go with angle R, so it's going to be 21. So we're going to say that angle UVS is much bigger than angle R. Okay. All right. In the workbook, let's go ahead and look at the workbook. There will be 2 sections on page 139. 3 through 22 is kind of broken into 2 sections. I think the first part of the work relates to comparing sides, so I think it's the stuff on the front. And on the back is where we actually start talking about the next topic in this section. So let's go ahead and talk about that. That's the triangle inequality. The triangle inequality is really simple, okay? So the sum of the lengths of any 2 sides of a triangle has to be larger than the length of the third side. So here's how you test to see if 3 numbers make a triangle. 2 plus 4 are the smallest 2 numbers in this set. 2 plus 4 is 6. 6 is greater than 5. So 2, 4, and 5 can be the lengths of a triangle. 6 and 8 are the smallest lengths of this set of numbers. 6 plus 8 is equal to 14. 14 is equal to 14. It's not greater than. So 6, 8, and 14 cannot be the 3 sides of a triangle. 8 and 8 are the 2 smallest sides. 8 plus 8 is 16. 16 is greater than 8. That can be 3 sides of a triangle. 6.5 and 6.5, that's equal to 13. 13 is less than 14.5. This cannot be the 3 sides of a triangle. Why don't you go ahead and pause the video and try 5 through 12. Okay, so hopefully you tried all these out. 7 plus 5 is 12, that's better. 8 plus 5 is 13. 6 plus 6 is 12. 3 plus 4 is 7. 2 plus 3 is 5, that's a no. 7 plus 3 is 10, that's a no. 9 plus 9 is 18, we're good. 14 plus 17 is 31. So again, if you're trying to make sure whether or not three numbers could make a triangle, that's how you test it. If the smallest two numbers is greater than the third one, you're good. You can also use this information to find the possibilities of a third side. So if, for example, numbers have to add up and be greater than the third one, what do I have to add to 6 to be greater than 19? Well, I would have to add 14, right? So 14 is the smallest number that I could have that would work. Well, what could I add to 19 to not be as great as possible? Well, 24 would keep 6 plus 19 greater than 24. So in order to find the missing measures, all you have to do is take your first two sides and you have to subtract the two numbers, in this case 19 minus 6, and then add the two numbers, 25. And whatever value you get, that third number must be between 13 and 25. So it could be 13.01, it could be 24.99, but it cannot be 13 and 25. For number 14, if I want to know the third side, all I have to do again, subtract and add. And the third side must be between 22 and 36. Go ahead and finish 15 through 21. Okay, so there are your answers. 14 is less than x is less than 40, 4 and 18, 2 and 16, 4 and 26, 7 and 31, 27, 69, 29, 93. The last thing I want to talk about is, okay, so let's take one of these and talk about the possible perimeters. So if I had 6 and 19, and we know that the possible third side is 13 is less than x is less than 25, how would I find the perimeter? Well, I would have to add the three numbers. So 6 plus 13 plus 19, right? So the perimeter has to be at least 30, well, over 38. But it has to be less than 6 plus 19 plus 25. So it has to be less than 50. So that's a way that you gauge the perimeter. There will be a question on the workbook work that covers perimeter. That's how you do it. Go ahead and answer this multiple choice question and then start the workbook work. When you're done, check it off with me and you'll be good to go.